In this video, we are going to talk about how we solve a quadratic equation using the quadratic formula. The wonderful thing about the quadratic formula is it works to solve every single quadratic equation, every one. So we first start by getting it into our standard form, ax squared plus bx plus c equals 0, same as we did for factoring. And then this is the formula. So remember what a formula is. It's an equation that works for every case. That's our formula. So to solve for x, we're going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice that under the square root is that discriminant that we've talked about before, that b squared minus 4ac. That's extremely important to us as it's going to distinguish between our types of solutions. So let's start by writing out our steps for solving using the quadratic formula. We're going to start by getting it in standard form. Remember that essentially just means we want it equal to 0. Determine the values of a, b, and c, same as we've been doing since we started factoring. You're then going to compute the discriminant, so the part that's under the square root. I do that separate just because it makes my work a little neater and I tend to make fewer mistakes when I do that. Then you're going to do the rest of the quadratic formula, and then you're going to plug in to check if possible. Some of the checking is just a little above our skill level, and we'll talk about that when we get to it. Now in this video, we're just going to do example 1. On the next page, you'll find examples 2, 3, and 4, but we're just doing example 1 in this video. So notice I'm already in standard form, so x squared minus 4x minus 21 equals 0. I'm already in standard form, so I can go right to picking my values for a, b, and c. So a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant. I'm going to start by doing my b squared minus 4ac. So plugging in negative 4 for b, with parentheses, you must have them, plugging in 1 for a, and plugging in negative 21 for c. And then following my order of operations. Negative 4 squared is negative 4 times negative 4, which is a positive 16. And then be careful with your signs. I always just look at my signs first. I've got minus and then a negative, so that's going to become plus. And then 4 times 21 is 84. Adding those together, I get 100. Now, this is positive, so I expect 2 solutions, 2 real solutions. This time I'm actually solving. So when we were doing the discriminant before, I was just saying how many solutions. Now I'm asked to actually solve. So, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. I do want you to write it because that's a formula that we're going to use often enough throughout the rest of your math classes. It's worth memorizing. Now here's what I'm going to do. I'm going to replace the b with negative 4. Be careful because that's negative. So that negative stays, and I'm replacing just the b with negative 4. Plus or minus, big square root. I'm not going to plug in all of the b squared minus 4ac. I already did it. It's right here. That's 100. I just do that because it helps me to keep my work a little bit neater. I tend to make fewer mistakes. Plus, I already know I'm expecting 2 solutions. And then all over 2a, and my a was 1. So I'm going to go through that again. I've got negative b plus or minus the square root of where I found my b squared minus 4ac all over 2 times a. I just used my formula. Now I'm going to simplify. So negative 4 is a positive 4 plus or minus. Hopefully you recognize 100 as a perfect square. The square root of 100 is 10. Notice that when I take the square root symbol goes away. So when I do the square root of 100, I get 10. Not square root of 10, 10. Now, because I've got no irrational part anymore, no square root left, this can be written as two separate expressions. 4 plus 10 over 2 and 4 minus 10 over 2. So I get either 14 over 2, which is 7, or I get negative 6 over 2, which is negative 3. So my two solutions here are 7 and negative 3. So I have two real and rational, in this case, two real and rational solutions. I do want to point out, if I were to look at the graph, I've kind of zoomed in a little bit. If I were to look at the graph here, so you can see my equation, x squared minus 4x minus 21, I get negative 3 and 7 as my two x-intercepts. I also want to point out that I could have factored this one. Anytime I get rational solutions, no square roots left, anytime I get rational solutions, that means I could have factored if I wanted to. The benefit of the quadratic formula is that it always works. We are going to look at the other examples in separate videos or together in class, depending on the example, just so we can kind of look at one or two at the same time.